Hello, and welcome to the expert-led workshop for HOL 2211-01. Let's go over the agenda real quick. First, we'll do some introductions so you know the team that brought you this lab. We'll talk a little bit about how we constructed and made the lab, as well as the lab experience itself, and then we'll dive directly into the guided lab and Q&A. So first, introductions. My name is Dwayne Callahan. I'm a staff solution engineer, and I'm a lab captain. I also worked with Blake Gilman, who's also a lab captain and a staff solution engineer, as well as Soumya Madhavan, who's a senior member of our technical staff, who was as well a lab captain. And then we had our lab principal, Jarrett Blandon. And these are the four individuals that were most directly involved with bringing you this particular lab today. Now let's talk a little bit about the lab environment. First of all, it's important to note that this is a nested environment, meaning that the ESXi hosts that you're using are actually virtual machines running on another hypervisor. Also, the pod that you're using is a shared pod, and it's shared across all the 2211 labs, which include 01, 02, and 03. You can search for 2211 within the HL catalog, and any lab with that number will be using this pod. Now, this pod consists of 10 layer 1 VMs, which are the VMs running directly under that hypervisor. And we have in there two environments. So we have split this up into Site A and Site B to replicate two different physical environments, and each one has their own vCenter server. Each environment also has two hosts, and there will be an additional VM called the main console. And this is the VM that you'll directly connect to when you work in the lab. We also try to follow the network designs of our VMware validated designs as much as possible. And so you'll notice that there will be a management network, a storage network, and a vMotion network. Now, it is also important to note that this particular lab environment is not connected to the internet. So if you open up a browser, you won't be able to Google search or connect to anything external to the lab pod itself. So it's important to note that although I mentioned the four individuals that helped build this lab, the HOL is a team effort, and we leverage the expertise across all of our specialties within VMware to bring you the environment. Also, because we're building this on vCloud Director, we can build pods and distribute these pods across many different cloud environments. And we use many of the same products that you use, such as vCloud Director, NSX, and vSAN. So this is the lab we're actually working in today. It's HOL 2211-01. And that is the vSphere What's New lab. And it consists of 6 modules. Now, due to time constraints, we won't be able to cover all 6 modules today in this workshop. But what we will cover is 2 of the modules. And those modules will be Module 2, Lifecycle Management, which will review some of the new features added in vSphere 7 that enhance lifecycle management and simplify your patching and updating processes, as well as vSphere with Tanzu. And this is new to vSphere 7. And vSphere 7 is vSphere with Tanzu, and it allows vSphere admins and developers to work together using native Kubernetes. So let's dive right into our first topic, lifecycle, upgrade, and patching. So what VMware calls lifecycle is really important. It's the idea that environments need to be patched and upgraded. Now, what can we do to make this better? And how can we reduce fear and build confidence in the process? Well, there's lots of improvements in vSphere 7. So let's talk about those improvements. So the Venerable Update Manager has gone really far, but with vSphere 7, we needed more. So we created vSphere Lifecycle Manager, or what we call VLCM. And the first thing we wanted to do is we wanted declarative configurations, meaning that when we say an ESXi host should look a particular way, we mean it. Nothing extra, nothing missing. Hardware firmware is also really important for security and reliability reasons. We want a definition of a host to include hardware firmware versions. And when we patch, We want the firmware updated too. Now, I'm sure everyone enjoys searching for and chasing down vendor tools or vendor ISO images, but they're all on my.vmware.com now, and they can be downloaded directly by VLCM inside of vSphere. So just select them from the list when you define what a host should look like, and that's it. Now, speaking of work people don't want to do anymore, there's also the idea of automated checks against our compatibility matrix. vSphere will just tell you if there's a compatibility problem with something like vRealize automation or vRealize operations. And the tools to do this are native to vSphere itself. Now, also with Lifecycle Manager, there's another difference between it and Update Manager, and that is that Lifecycle Manager understands vSAN at a very deep level. vSAN has concepts like fault domains, and VLCM will respect those so that it reduces or minimizes any loss of availability while also getting the updates done. And also, there's the concept of the Converge platform service controller, and vSphere 7 automatically converges it for you. So many customers are hesitant to upgrade now, thinking about the experiences they had with vSphere 5.1 or vSphere 5.5. And a lot of work has gone into making the upgrade experience smooth, and upgrading from vSphere 6.5 to 6.7 is very straightforward. Now, again, with vSphere 6.6, we had the platform service controller, and we announced that that was deprecated in 6.7. Now, I want to point out when we say deprecated, that doesn't mean that it's unsupported. It just means that it's going away in the future as the platform evolves. And with vSphere 6.7, you could potentially manually converge the platform service controller into the vCenter server. But we don't recommend or suggest doing that. What we suggest is that when you upgrade to vSphere 7, just let the vSphere 7 upgrade process automatically converge it for you. So that way, when you go to upgrade, it's taken care of. And it works very well. And if you use link mode, then there's just one additional step that has to be done to turn the replication process back into a ring. And that's all well documented and available for you. So let's also talk about another thing that comes along with Lifecycle Manager. Starting with vSphere Update 2, you can now also deploy vSphere with Tanzu on an LCM-enabled cluster. So vSphere with Lifecycle Manager now handles vSphere with Tanzu as well as NSX-T Lifecycle. So that makes it pretty easy and pretty much covers any deployment model for Tanzu, and it's all covered by Lifecycle Manager now. One other feature is we've introduced the vSAN and LCM Bootstrap capabilities via the vCenter CLI installer. So this will allow you to create a single node vSAN cluster and deploy vCenter directly on top of that. Also, if you set the enable-VLCM option to true, the cluster will be configured with a single image. And one last item, we did give the ability to now extract LCM images from an existing host. So with this, as an administrator, if you have a host that represents what you would like the environment to look like from both a patch and upgrade level to a firmware level, then you can use that host as a model host and actually create your LCM image based off of it. And one more item is this concept of suspend to memory. And this introduces a new option to help reduce the overall ESXi upgrade time. Now, during an ESXi upgrade process, the normal policy is to put it in maintenance mode, wait for all the VMs to be live migrated off, and depending on the workloads and the size of those workloads, It can range from several minutes to several hours, depending on things like network bandwidth and spare capacity that's available for the migrating VMs. So what suspend to memory does is it gives you another option when you're upgrading. This new option will suspend the VM state into local host memory during the upgrade and remediation process. And then once the host is upgraded and the VM kernel is restarted, using Quick Boot, the VMs are unsuspended and they continue to run as if they did before. It's also important to note, though, that suspend to memory builds upon Quick Boot, so that is a requirement. But that feature was released in vSphere 6.7. And with that, we'll go ahead and begin Module 2 in the lab. And with the lab environment, I recommend, if you can, you have the ability to jump straight to modules. So in your lab, I recommend jumping straight to Module 2 and beginning Module 2. And in Module 2, you will cover things like creating a Lifecycle Manager profile, importing an ESXi image into Lifecycle Manager, assigning that as a baseline and attaching that to a host, and then having that host check for its compatibility against that new baseline. Now you are free to pause the video and proceed to Module 2 and complete that, and then unpause this video when you're ready to continue to the next topic. So let's talk about vSphere with Tanzu now, our Module 5, or second item for this expert-led workshop. vSphere with Tanzu is the Kubernetes functionality built inside of vSphere. And this was originally released as vSphere with Kubernetes. But we've merged the names into the larger family of modern application tools, which is now called Tanzu. And Tanzu as a name means a few different things globally, but mostly it's centered around skilled work, which is exactly what DevOps teams are known for. Now, if we look at applications today, and this is where we'll start, we'll talk about applications. The definition of an application has begun to change, or it is changing. It's not completely changed for your environment. And we used to have what was on the left, and that's your traditional monolithic application with an app server and a DB server. And those usually were individual virtual machines, and that may have been considered an application node. Or you could have had a web server in there, and that was basically what made up your application. And they were confined, each function confined to its VM. But modern applications are becoming more of a distributed system. Thanks to microservices and containers, we're seeing the application become far more distributed and far more compartmentalized as far as what the functions do. Now, with that means that we also have different priorities for modern applications. From a developer perspective, they're really concerned about self-service. They want to code the application, test the application, get it out there deployed, and then pass it off to the support teams and move on to the next application. And they really want this to be available on demand. They don't want to have to put in requests to infrastructure teams or to networking teams or security teams, wait for those requests to get processed before they can start developing their code. Whereas though the vSphere admins have other concerns, and that's governance. First, they need to know, does this application need to be highly available? Should we put load balancers in front of it? Also, let's talk about security with it. Does it need firewall rules? Does it need ports opened up? Does it need to be in the DMZ, or can it be on the internal network? And they're also concerned about the quality of service this delivers. What's the uptime considerations need to be? And finally, cost control is there. They need to be able to provide services within the budgets and cost constraints the business has outlined for them. So this leads us with, how do we solve this problem? Well, that's where vSphere with Tanzu comes in. vSphere with Tanzu really is a simplified deployment and consumption model for Kubernetes. It allows the developers to consume Kubernetes using the same Kubernetes interface they're used to, but it also allows vSphere admins to deliver that on the constructs they already know, like vSphere and vSAN and NSX. Now, let's talk a little bit about how this is delivered. So vSphere with Tanzu gets this done by building on top of the existing SDDC. Then what we do is we layer on something called a supervisor cluster, which is a special kind of Kubernetes cluster that uses ESXi as its worker nodes instead of the more traditional Linux virtual machines. You might remember us talking about this at VMworld a couple of years ago, where we boasted that workloads that run this way are 8% faster than on Linux. Well, it's true. ESX really is the most efficient hypervisor around. Now, on top of the supervisor, we define a namespace. And a namespace is a Kubernetes term, but on vSphere, it also maps to standard vSphere constructs like resource pools, security policies, and availability policies. And and from there, what you can do is you can use standard APIs to deploy workloads onto the supervisor clusters. Or if you want, you can just create Tanzu Kubernetes grid clusters or TKG clusters, which are types of clusters that look and act exactly like open source Kubernetes software. Now, one common question we get is, why are there two types of clusters here? Well, each cluster meets a different goal. The supervisor cluster does not act exactly like an open source Kubernetes. In fact, it's meant to be more of an interface between vSphere and Kubernetes, extending Kubernetes extending vSphere using the Kubernetes interface itself. And so this makes things a lot more flexible and gives you the ability to choose what you would like to do for your own solutions. So another item with Tanzu is we made the promise to always keep up with the upstream Kubernetes open source versions. And we're continuing to uphold that by delivering new versions with updates to vSphere. So for example, Kubernetes 1.19 shipped with vSphere Update 2 for both TKG clusters and the supervisor cluster. And maybe by the time you're listening to this, we're probably shipping whatever the latest version is. So this lets developers use the newest features and run the newest applications while bringing the stability and reliability of vSphere along with it. One other item, vSphere with Tanzu ships a fully supported, integrated, and highly available enterprise class, enterprise ready load balancer for Tanzu Kubernetes Grid Control Plane and for the Kubernetes service. So it's fully integrated and orchestrated. So that means that when a developer team builds it into their application definitions, Tanzu will just use it. So the developers don't need to understand the infrastructure. And the people that understand the infrastructure, the vSphere admins in this case, can now deliver a load balancer that scales automatically to match the workload's needs. And with that, we'll go ahead and begin module 5 in the lab. Again, my recommendation in the lab is to go to the table of contents, jump straight to module 5 and begin module 5. I will note that module 5, due to size constraints within our hands-on lab pods, we weren't able to actually install Tanzu within the pod. So what you'll be running in this particular lab module is an interactive simulation. So you are now free to go ahead and pause the lab or pause the presentation while you take module 5. So with that, I would like to wrap up this expert-led workshop. And just a note, please take your survey. Those are very important to us, and we definitely use that for feedback to improve these expert-led workshops. And I'd like to thank you for being a part of this expert-led workshop. Have a great day.